page 85 and the topic is slab with splayed edge beam. So in the previous lessons we've done slab with a thickened edge beam, but in reality your edge beam is going to have a 45-degree angle roughly on the edge. So this will stop it from breaking, the concrete cracking there. So we splay it. It's known as a splayed edge beam or a raft edge beam, and we've got to do the calculations on that. So first of all, we have to do the calculations for the slab. So that will be this thickness here, and then we've got to do the edge beam. So an edge beam is just a footing added to the slab, but it's usually poured at the one time. So if we look at just what the shape of the edge beam is now, it is this unusual shape here. But in reality, we can make it into a rectangle, and there's a way we can use our extra triangle here. So I've just got, I've got an edge beam, and we actually have a triangle forming. So we're going to use what we know about triangles to work out the calculations for this edge beam. So we're going to go over to the next page, and it's going to show you what we want you to have a look with the calculations. Now, the width of the edge beam is 500 at the moment and 300 deep. However, we've got this splay and we have to calculate this extra area. So what we can do is we can look at this triangle, taking this triangle from up the top and moving it down here to make it into a rectangle. Okay, so this is what it will look like when we're presented with a job. You'll have this slab, your edge beam underneath, and then this is with a splay. So we're going to break the picture down. So our slab we're going to get is going to be like normal, length times width times depth. Length times width times the depth is 120 there. So we get our figure of 3.411 meters cubed. So now, that's our slab. So we'll go over the page, and we've got to work out our edge beam now. So we've got to work out the depth. The overall thickness is 600, but 120 goes for the slab. So 600 minus 120 is going to give us 480. So that's our depth there. So we're going to use that. We're going to make this a little triangle here. And we're going to look at our triangles, and we are using what we know as an isosceles right angle triangle. So if that's 90 degrees in the corner, 45 degrees in one corner, the other corner must be 45. This side must equal the other side. So we're going to use that knowledge for this rule. So what we're going to do is we're going to halve the depth. So half of 480 is 240, and we're going to add it to the width to make this like a rectangle. So that 620 is 380 plus the 240 makes 620. So to work out the calculations on this now, we have our edge beam. We're going to do our intos and overs. This is what our edge beam now looks like for changing from our splay. There's our width, there's our depth. So now to calculate the length of the edge beam, we're going to minus the new width of 620, not the 380. We're going to be minusing 0.620 on each of these, and that will calculate the new length here. So we do our volume, length times width times depth, and that's going to give us 20.18 times 0.62 times 0.48, and we get our new figure. Now we have to add our two figures, the figure from the slab and then the edge beam, and I haven't got my piece of paper. Right now I've just got to go over the other side. Sorry. So we've got our volume for our slab and our edge beam. We have that together, and then we're going to add our waste. Now we get a volume of 9.857. We can't order that. We're going to order our 10 metres cubed. Okay. We'll go on to exercise 26.